Food science meets explosive force, where a simple pencil can blow your mind. Pencils are a ubiquitous tool in every household, used by children and adults alike for creative expression and academic purposes. However, what lies beneath the surface of this seemingly ordinary object is a world of fascinating chemistry and physics. The graphite core of a pencil is made up of tiny, tightly packed carbon crystals that are infused with clay and other minerals. These carbon crystals are incredibly strong, yet delicate, and can be easily damaged by exposure to heat or moisture. But that's not the strangest part. When a pencil is sharpened, it can create temperatures hot enough to melt steel. This is because the friction generated by the sharpening process creates a tremendous amount of heat, often exceeding 800 degrees Celsius. In fact, if you were to hold a pencil against a hot surface, it would likely catch fire and explode with the force of 1 billion nuclear bombs. So, what makes a pencil so explosive, and how does it relate to the chemistry of carbon? To understand this phenomenon, we need to delve into the world of graphitic carbon and its unique properties. Graphite is a soft, black mineral made up of layers of carbon atoms that are arranged in a hexagonal structure. This layered structure gives graphite its characteristic slippery feel and allows it to conduct electricity. But when graphite is subjected to heat, pressure, or other forms of stress, it can undergo a process called graphitization. Graphitization is a complex process that involves the rearrangement of carbon atoms into a more stable, crystalline structure. As graphite undergoes graphitization, it releases a tremendous amount of energy in the form of heat and light. This energy release is what makes a pencil so explosive when sharpened, and it's a key factor in the development of advanced materials. But graphitization is not just limited to pencils. It's a crucial process in the production of advanced materials like graphene and nanotubes. Graphene, in particular, is a highly conductive and strong material that has the potential to revolutionize industries, from electronics to medicine. And it's all thanks to the incredible properties of graphite and the process of graphitization. So, what can we learn from the humble pencil? And how can we apply its secrets to create a better future? For centuries, humans have been fascinated by the properties of carbon, from its ability to conduct electricity to its incredible strength. And at the heart of it all is the graphite core of a pencil, a tiny, yet mighty source of explosive force and endless possibility. But that's not the end of the story. As we continue to explore the world of graphitic carbon, we may discover even more surprising secrets. For example, did you know that graphite can also be used to create highly efficient solar cells and fuel cells? These advanced materials have the potential to transform the way we generate energy and power our homes and devices. And it's all thanks to the incredible properties of graphite and the process of graphitization. So, what's next for the world of graphitic carbon, and how can we continue to harness its power? One thing is certain: as we continue to explore the secrets of the humble pencil, we may just uncover the key to a brighter, more sustainable future. The possibilities are endless, and the potential for discovery is vast. So, let's keep exploring and see where the journey takes us. Thanks for joining me on this journey into the world of food science and cooking chemistry. If you found this fascinating, subscribe for more incredible stories like this. And don't forget to like and comment below with your thoughts on the incredible properties of graphite. See you in the next video. Thanks for watching.